to learn, put your mind to.
I'm sorry to tell you, but if you don't chase it, it's not going to come to you. This applies to everything in life. Think about that. Boom! Okay, we're about to start. Today we'll be doing some financial maths. That's what the next topic is that we'll be dealing with. Right? So, let's get started. Let's look at the basics of the things that we should already know, that we did in grade 11 already. Those are the basic things that you should have at the back of your mind. You don't even need to. You shouldn't need to look at the formula sheet to know what the formula is for these things. So I'm just going to write the formulas down. So take out your exam pad, your pen, your pencil, whatever you write with, and let's get started. So the first formula, of course, is the simple interest formula. That's the easiest formula. Let me write financial math. Right, the simplest formula is the simple interest formula. Okay, what does a simple interest formula look like? So basically, this is what the formula looks like. A is equal to P 1 plus I times N. And you already know that A is the amount, P is the amount that's deposited or that you start with. And I is the interest in a decimal or in a percentage. So let's say they say 12% interest rate. The number you put in over here will be 0.12, right? And N is the number of years. Okay, so what's the next formula that you should know? The next formula that you should know is the compound interest formula. You did all of these, so you should remember this. This is just revision. So this is compound. Alright, and yeah, A is equal to P 1 plus I to the power of N, right? That's what the compound interest formula looks like. So, now you know these formulas already. These formulas are formulas that you did last year. So you should remember them. They're formulas that you should already know. So, let's look at another formula, simple decay. What does a simple decay formula look like? It looks like this. What is decay? Decay is to decrease, right? So simple decay just means that instead of having a plus, which is increasing, causing compounds, interest, we have decay, which is decrease. So simple decay formula would look like this. Alright? There's the only difference between these two, simple interest and simple decay, is the minus sign between the two. Because we are minusing, we are decreasing in value. So that's why we're minusing that, whatever that interest rate is. Right? So the other formula, the last formula, is the reducing balance formula. This one, yeah, I'm pretty sure you know this by at the back of your mind. Right? Let me write it here. Okay, what is the formula? The formula is A is equal to P1 minus I to the power of N, right? Again, the only difference again is the negative sign that's between the 1 minus the I, right? That's the only difference that's here. So these formulas here, you should commit them to memory. You should remember them. There's no need for you to go look at the formula sheets to know these formulas. So basically, these are the formulas that you need to know, right? For the meantime. So let's do an example. Let's just refresh your memory so that you know what I'm talking about. So my example is example 1. Okay, so the question is, a car costing 200,000 depreciates at a 16% per annum on a reducing balance. Calculate its cost after 4 years. So this question is pretty straightforward. I'm pretty sure you remember how to do this. So you can go with me. Don't just watch me do it. Go along with me as I'm teaching, as I'm doing the example. Also do it on your own over there to see if you can get to the answer before me. We'll see about that. So what do I do? What's the first step? The first step is I get the formula. What is the formula for reducing balance, because that's the key word over there, reducing balance or depreciates. It means that it's decreasing. If something is depreciating, it's decreasing in value. So my formula would be, of course, hard work definitely pays off eventually. But don't just work hard. You have to work smart too. Because there are a lot of people that work hard but don't work smart. So they end up tiring themselves, getting fatigued before they write their exams or before they do the important thing that they want to do. So you have to work hard and smart. There are certain things that you don't need to be doing where you are wasting time, doing a lot of busy work. The one with the negative in between it. So it'll be A equals to P 1 minus I to the power of n, right? What values do I know? So what's the initial value? The initial value is 200,000 because that's the value that it costs right now, right? That's the cost of the car right now. But in 4 years' time, it'll be a certain amount, which will be A. So that's why we replace P with 200,000, which is the cost of the car right now. 1 minus I. What is I? I is 16% per annum, right? But we can't write 16 as a whole number. We have to write it as a decimal place. So it will have to be 0.16. 0.16 to the power of what? How long are we looking at the depreciation over? We're looking at over for 4 years. So we want to know what the price would be after 4 years. And we know for a fact that it has to be lower because this is a depreciation. If it's depreciation, the price cannot be higher because it doesn't depreciate up. That doesn't make sense. So the price of the car will have to be lower than 200,000. So let's see what answer we get. To the power of 4, which is equal to, the answer that I have here is 99574.27. Don't forget what unit this is. When you're working with money, you have to put the unit that is in rands, right? Or whatever unit they give you, they might give you in dollars. So if I look at my value now, the car costs at the beginning right now, it costs me 200,000. But at the end of 4 years, if I want to sell that car back to the dealership, that car will cost, they'll say, we'll only give you 99,000. Most of the time, they won't even give you that much. So that's how it depreciates over 4 years. So that's why they always say a car is a depreciating asset. No matter what happens, the value of the car will always be less as soon as it leaves the dealership, right? So that's my final answer right there. So that's pretty straightforward. That's pretty easy, right? Next, okay, let's go to the next one. Example 2. Okay, so my example 2 reads, if a Sander puts 2,000 in a savings account for some red bottoms, okay, which is compounded monthly at 8% per annum, how much will she have after 2 years? So she wants to save for some red bottoms for 2 years, which is commitment. So let's see how much you have after 2 years, right? So what's the first step? The first step is to determine what formula I'm going to use in this. What formula is the value that I put into a savings account decreasing or is it increasing? Of course it's increasing. It's savings account. It has to increase unless you're taking money out. Then that's a different story, right? So my formula which I'm going to use will be the simple compound, the compound formula, right? To the power of n, right? That's the formula that I'm going to be working with. So now that I have this formula, right? What values do I know? Because I know P is the value that we start off with. So since P is the value that we start off with, it's equal to 2,000, right? Let's put that value in. So this is 2,000, right? So now inside we have 1 plus I. What is the percentage? The percentage is 8%. But I can't write 8. I have to write it in decimal form. So again, what is the decimal form of 8%? It's 0.08. And no, it is not 0.8. Be careful with your maths, okay? to the power of, what is the number of years? How long is the duration of the savings that she is putting money into this? It's for 2 years. That's how long she wants to save for this. So now we have this. Now, what do we need to do? Just put in the calculator and see what value that we get. So the value that I got was right? My value is 2345.78 rands. So after 2 years of saving, right, Asanda has 2,345.78 cents. Does that make sense to you? That's crazy. For saving for 2 years for some shoes for red bottoms, there's no way she's going to buy them anytime soon. So I think she should just spend the money, you know? Give it to me maybe. So yeah, so that's the answer. So this is pretty straightforward. There's nothing too complex about this. You should try some examples, some different examples so that you get comfortable with these things. These things are not difficult. These are your free marks in your exam. Okay, so now we're going to move on to nominal and effective interest rates. I'm pretty sure you remember this stuff. This stuff was 3 marks. It was easy. You knew the formula. If you knew the formula, you could get the answer with no hassle. Right? So let's get on to it. Let's look at it. Let's look at the formula, what the formula looks like. Because it's the important thing here. So let me write here nominal and effective nominal and effective interest rates. So the formula, what is the formula? I hope some of you still remember what the formula is. So get your pad again, start writing, don't just look at me. Do something, right? The formula is 1 plus IEF, I effective, is equal to 1 plus I nominal to the power of n, right? So write this formula down if you don't remember it, okay? Write it down, commit it to memory so that you know this formula. So that when a question comes up, you can do this and get your free 3-2 marks, okay? So we know that IEFF is I effective. I nominal, that's I norm, right? And n is the period. How long is the duration? How often is it, like, is it quarterly, yearly, or monthly? Which will be 12 or 4 or 2 or whatever the case might be, right? So let's do an example so that we know what I'm talking about, so that we get comfortable with this stuff, because this stuff is not complicated, right? Example 1. Okay, so the question says you have, let's say, an interest rate of 10% per annum compounded semi-annually. Find the effective interest rates. This question is pretty straightforward. So what do I do? What's the first step? Okay, what do I know already? I know that this 10% compounded semi-annually means that it's compounded how many times? Once every 2 months. Once every 6 months. So that's twice a year, right? And 10% is the I nominal, right? So let's write the formula down. So let me replace the values that I know. What do I know? 1 plus YEFF. I do not know what this is because why? That's what I'm looking for. So let's move on to the next part. I nominal. Do I know what that is? Yes, I do. I know that is 10%, but I can't write it as 10 or just 0. Or I can't just write it as a decimal point. What do I have to do? I have to say over what period is this compound interest paid out in? Is it quarterly, monthly, or semi-annually, right? So since this question is saying it's semi-annually, right? So it'll be 0.1 divided by 2 to the power of what? To the power of 2, right? So Now, this is pretty straightforward. What you could do is, you could solve for what's on this side first. And once you have solved for what's on this side, then you take the 1 onto the other side and subtract it. But do not round this number off before you subtract the 1, because your answer might be a little off. So, what do? I'll take my 1, I'll take this in the calculator, and then I'll minus the 1. Right? So, my answer should end up being but I can't leave my answer like that, right? So I have to write it in a percentage format. So in a percentage format, it will look like this. You have to plan for your exams to start studying before they begin. I would say a minimum of 3 weeks before exams begin, you should have already started studying. You should make a detailed plan, include a daily plan to say that today I'm going to be reading maths, tomorrow I'm going to be reading this. It has to be detailed daily timetable for the 3 weeks before your exam begins. 3 weeks. So before all your exams begin, you should have gone through all of your exam papers. You should be ready to write all of the tests. And then during exams, that's when you can sleep earlier, and not to be lazy, but so that the day before your exam, you are prepared and you are well rested. Those things are important, although they might not seem important when your LO teacher says it. Those things are important. And basically, that's the answer. That's your 2, 3, 4 marks for free. Really, like there's nothing much to that, right? Okay, so let's move on. Okay, so now let me tell you something new that you might not have known, that you might not have learned last year. Something new. What is this? This something new is it's converting our interest rate from compounded, let's say monthly, to compounded annually. So you want to convert that 12% compounded monthly to another percent, that 12% compounded yearly, let's say, semi-annually, right? So what do you do? How do you change that? There's a formula. So let's write down the formula so that you know what I'm talking about. One plus I new to the power of m is equal to 1 plus I nominal over to the power of n, right? So what is I new? I new is the new value that you have that is compounded to the new value. So if you say converted to compounded monthly, now I new will be the interest rate compounded monthly. And I nominal is the value that you already have that they gave you, right? And M is the number of periods. M is the number of periods at the new compound interest rates, right? So let's do an example so that we can see practically what I'm talking about. Okay, so my example 1 reads, convert 15% per annum compounded quarterly to interest rate compounded monthly. So that's what I was talking about. So it's from quarterly to monthly, right? So we want to change that value there so that we can write it, so that we can work with the monthly interest rate, right? So what do I do first? I take my formula and I put it down so that we can see what we have and what we don't have. So my formula reads 1 plus I new to the power of m, which is for the new interest rates, 1 plus I nominal, which is the value that we already have, to the power of however many payments per year was originally, right? So what do I know? Do I know I new? No, that's what I'm looking for. Do I know m? Yes, I do. I know the number of times I want it to be converted into, right? What would be m? M would be 12. Again, write this down. I hope you're writing down. Follow with me. Right? I knew, I don't know what it is, that's what I'm looking for. M, I know what M is because it says we want to convert it to compounded monthly. So M will be 12, the new number that we want to convert it to. And N would be quarterly, which would be 4, the original number. Right? So let's write it down. Let's write down what we know. 1 plus I knew, which I don't know, to the power of M. M I know is 12 because that's the new value that I'm looking for, the compound and monthly, that's what I'm converting it into. 1 plus I nominal, then the interest rate nominal would be 0.15, right? And what was it already? It was 4. It was quarterly, so it is to the power of 4, right? So now what do I do? Now it's straightforward. I mean, what's so complicated about this? Okay, so let's look through it, right? First, I could solve for this first. I could solve for this and work like that. But again, your number will not be as accurate if you solve for this and then you round off and all that type of stuff. So what I suggest is you keep this as it is. But first, how do I eliminate the exponent? The exponent 12, I want to get rid of the exponent 12. So what do? I take the roots, the 12th roots on both sides, right? So if I take the 12 roots on both sides, like this, what do I have this side? This roots and that square will cancel out, and there will be no more exponent 12. So this will be 1 plus I nu is equal to. Now on this side, I can't just cancel out anything because this is 12 and that's 4. So I don't know what it is. So what do? I just write it as it is, right? Because I want to put all of this in the calculator so that when I get a value, it'll be close to as accurate as possible. And also, this answer will be the answer that's on your data sheet, not the one that's rounded off. So you might get a question wrong because you rounded off too early, right? So now I have 1 plus I. I knew. So what do? I take the 1 onto the other side. So now this is what, if I take the 1 onto that side, right? So it will be minus 1 here. And then it becomes minus 1 on that side, right? So now I knew will be equal to. So you just put all of this into your calculator, and the value that you should get is oh yes, my bad. Okay, I knew. Okay, the value that I knew, right? But I knew, the problem is what I didn't do over here. I knew is not just I knew, right? Because as you can see on the other side, also on this one, which I forgot to add, is that this is divided by 4. That there is divided by 4, right? So this side also has to be divided by 12, yeah, the original value. So now my equation reads the 12th roots of bracket 1 plus 0.15 over 4 in bracket to the power of 4, right? You should remember this. I almost forgot about this, right? Minus 1 at the end. So now what do? I knew if I want to get rid of the 12 on this side, okay, let me just write it. 1 plus 0.15 over 4 to the power of 4, right? Minus 1. So now I knew to get the final value, I have to multiply both sides by 12. And if I multiply both sides by 12, and then I'll just put this in again. Don't resolve this yet. Resolve it only when everything is on one side. So once the 12 has been taken onto that side, so once I have multiplied by 12 on both sides, so this whole thing multiplied by 12. Multiply by 12. So what's the final answer? The final answer that I got is 0.1482, which is also equal to 14.82%. So what was the original thing? The original thing was 15% was compounded quarterly. 14.82 is compounded monthly. So of course the values will not be the same because they are compounded at a different rates. That one there is quarterly, that's 4 times a year, and that one there is monthly, which is 12 times a year. So yeah, that's basically it. You might come across this question, and when you do come across it, it should be easy because as you can see, it's not that hard. Okay, so see you next one. Go to the next video. Boom.